So here's a summary of everything that we've talked about so far in this section. And so the last two examples we're going to look at are just putting all this together and asking all these different questions about the degree and turning points and the zeros and the behavior near the zeros and all that kind of stuff. So let's dive in here. For the polynomial x cubed plus x squared minus 12x, first find the x and y intercepts. Determine whether the graph crosses or touches the x-axis at each x-intercept. Talk about the end behavior. Find the power function that the graph resembles for large values of x. The maximum number of turning points, the behavior of the graph near each x-intercept, and then put all that together to obtain a graph of f. And if you haven't caught on by now to what we're doing is we're taking a function, some polynomial function, and we're just looking strictly at this function and gathering information about the graph of that function. So, I know we could easily put that into our calculator and see a picture of it, and from that picture we could get the x and y intercepts, and we could see what the ends of the graph do and what it looks like near the zeros. But it's good to know, without having to graph every single function, just some of these things. What's the end behavior going to look like for this function without having to graph it, okay? Because some of these is pretty quick and easy to figure out. So one thing that's helpful as you start into this is if you can factor your function at all, that's going to help you as you start to answer some of these questions. So x cubed plus x squared minus 12x. If you want to factor that, first you notice there's a common factor of x. And then two numbers that multiply to negative 12 and add to 1. How about x plus 4 times x minus 3? So my function, we can factor that and get x times x plus 4 times x minus 3. And you'll see why that's helpful here in a moment, to have both of these forms. Alright, so let's just dive into our questions here. Part A, x and y intercepts. Now for the x-intercepts, what are those the same as? Those are the same as the roots and the zeros. And again, we factored that function for this particular question. To find the x-intercepts, we can look at these factors. So I've got an x factor. You could think of that as x minus 0. Okay, so that's an x-intercept at 0. This one would be an x-intercept at negative 4 and at positive 3. For my y-intercept, for your y-intercept, remember that means that x equals 0. So if x is 0, 0 plus 0 minus 0, right? Wouldn't all these terms be zeros? So my y-intercept is 0. Part B, determine whether the graph crosses or touches at each x-intercept. So let's do it like this. Thinking about multiplicity, aren't all three of these the same? They're multiplicity 1, and that would mean that it crosses at all x-intercepts. They're all odd multiplicity. Find the power function that the graph resembles for large values of x. The power function comes from the term that tells you the degree. That's x cubed, so y equals x cubed is the power function that determines the ends of the graph. So that's all we need there. Part D, maximum number of turning points. It's a third degree polynomial, so we have a max of 2 turning points, one less than the degree. part E, and part E is the trickiest question. Determine the behavior of the graph of f near each x-intercept. So what's this graph going to look like near x equals 0, x equals -4, and x equals 3? So I'm going to have 3 different questions here. So near each x-intercept, what's this thing going to look like? Okay. So we always start with our function. In the factored form for this question on all 3 of these. Okay, now near x equals 0, which factor did that come from? It came from this guy, right? So I'm going to plug in 0 into the other 2 x's. So this x stays, the others get a 0. If I simplify this, 4 times -3 is -12x. So near x equals 0, this graph will look like -12x. That's a negative slope. Okay, so it's going to be going down from left to right. Okay, the next question, x equals -4, which factor did that come from? That was this guy right here, the x plus 4. So I leave it alone. I plug in the -4 into the other 2 x's. Okay, so I get -4 times x plus 4 times -4 minus 3. -4 times -7 is 28. So I get 28x plus 112. For that one, that's a steep positive slope. It's kind of the main thing you can take away from that. And then the last one, x equals 3. Again, that 3 comes from this x right here. So we plug it in to the other 2 x's. So we get a 3 times 3 plus 4 times x minus 3. 3 times 7 is 21 times x minus 3. So 21x minus 63 would be the behavior near x equals 3. Okay, that's the toughest part of this whole question, is just getting all those behaviors near each x-intercept. But we got them. That'd be these 3 right here. So the last thing is to put all this together to obtain a graph of f. So let's do that. That's not a straight line at all. Okay, so my x-intercepts are at 0, -4, and 3. So let's just throw those up there. And what's the ends of my graph doing? In behavior, looks like y equals x cubed. That was part C. So that means what? The left end of my graph is going to go down. The right end is going to go up. And what does it do between those? Well, we know it crosses at each x-intercept. We also know that At 0, it's a slope of negative 12x. The other two x-intercepts have a slope of 28 and 21. So these we could think of them as being something like this. Again, this is just a sketch. I don't expect you to draw an absolutely perfect graph based on that information, but really it's just to get an idea of what the shape of the graph looks like and where the x-intercepts are. Okay. And I think on the homework for this, you're just picking a multiple choice of which picture the graph looks like. So if you can really figure out where it's crossing and you know which direction it's crossing each x-intercept, where it's going up, where it's going down, that'll be enough to get you what you need to know. Okay. And I just noticed I copied the same problem twice here, which was a mistake. This question right here, let me just fix it real quick. It's the same question, we're just using a different polynomial. Okay, so same question, all the same stuff, different polynomial. So let's run through these. A, x and y intercepts. Now this is already factored, right? So pretty easy to see the x-intercepts. They're going to be 0, 4, negative 1. So part A, (0, 4, negative 1). For the y-intercepts, now you should know, hopefully, or maybe you caught on by now, if you have an x-intercept at 0, don't you also have a y-intercept at 0? Because at x equals 0, you also get that y value 0. So that thing crosses at the origin. That's what we're saying there. So we do have a y-intercept at 0. X-intercept at 0 guarantees that. Does it cross or touch at each x-intercept? That goes back to the multiplicities. X squared is even. That means it's going to touch, right? Touches at x equal 0. That's the x squared. The other two are just single factors, x minus 4, x plus 1, so those are going to cross. Find the power function that the graph resembles for large values of x. It's good to have this thing multiplied out. So let me copy it down here. So to get this, first we can FOIL. We FOIL and combine like terms. We get x squared minus 3x minus 4. And then distribute the x squared. We get x to the 4th minus 3x cubed minus 4x squared, which tells us part C, x to the 4th is what we're looking for. The ends of the graph are going to look like x to the 4th, that highest term with the highest power of x. D, maximum number of turning points. What's the degree of that polynomial? 4th degree. So we'll have a max of 3 turning points. One less than the degree. Part E is the part we all love. Near each x-intercept, what's the behavior? So near x equals 0, positive 4, and negative 1. Again, we're starting with the same function each time. in factored form is the best way to work with it on this question. Bear with me as I copy this. Okay, so we got to think about first which factor did this 0 come from. X equals 0 came from this guy right here. So we're going to plug in 0 for the other two x's. Okay, and just to kind of continue that thinking, where did 4 come from? Came from this guy. So we're going to plug in 4 to the other two. And where did negative 1 come from? Came from this guy. So we plug in negative 1 to the other two factors. Okay, so make sure you see that and kind of get that. That's where most people mess up, is when they're plugging in those values. So you just leave the factor it came from alone, plug in the x value everywhere else. So if we work that through now, this x squared staying the same, plugging in zeros here for the other two. Looks like we get a negative 4x squared. So that one's done. 4 goes into both of these. So that's a 4 squared, x minus 4, and 4 plus 1. So 16 times 5 is 80. X minus 4, so that's 80. X minus 3, 20 for that piece. And last one here, negative 1 goes in for both of these x's. So that's negative 1 times the negative 5, so 5 times x plus 1. It's 5x plus 5. So there's my 3 answers for the behavior near those x-intercepts. And last part is to put it all together and get a picture of this thing. So I've got x-intercepts at 0, at positive 4, and at negative 1. Okay, the ends of my graph, what are they doing? This thing touches at 0, crosses at 4, negative 1. Ends of the graph look like x to the 4th. So this end's going up, and this end's going up. And it's touching at 0, right? So just basing the rest of this on what I know about the behavior near the zeros. Near x equals 0, it's a negative 4x squared, so that parabola opens down. Near x equals 4, there's a slope of 80. That's doggone near straight up. And x equals 1, there's a slope of 5. So that's pretty level off. So just to kind of see if I can get this to be pretty close. This is really steep. It's going to be something like that. And there it is. That's the last example from this chapter. I know it's a lot of information, especially those long questions, but Take it one piece at a time. If you have any problems or any other questions, feel free to let me know.